Bismillahirrahmanirrahim. Straight line. Here we are going to discuss the coordinate geometry of class 11, in which first of all we are going to explain what is the slope of the straight line. Suppose here is, in this figure it is the coordinate Cartesian product. It is the Cartesian coordinate in which x o x dash and y o y dash as the axis which intersect at the origin O. AB is a straight line which makes theta positive angle with the positive direction of x-axis. Then we represent slope. Slope is equal to tan theta, and slope is also known as gradient. Now if we are taking 2 points x1 y1 and x2 y2, then the slope of the straight line passing through the points x1 y1 and x2 y2 will be m is equal to y2 minus y1 divided by x2 minus x1. And another thing, there are various forms of equation of a straight line. First form is slope intercept form of a straight line. So the equation of a straight line which makes C intercept on y-axis. Intercept means what? The distance from the origin in x-axis or y-axis. Suppose a straight line intersects the two axes at different points, then the distance of the point of intersection from the origin in y-axis is known as y-intercept, and the distance of the point of intersection on, suppose that it is the Q I have taken, so OQ is the distance from the origin to the point of intersection of the straight line with x-axis, then this distance is known as x-intercept, and OP is y-intercept. Here the OP is taken as C. C may be positive or may be negative. If C is above means in the positive direction, positive y-axis, then C will be positive, and C may be 0 at origin, and when C is in the negative y-axis, then C will be negative. So under such type of condition, y is equal to mx plus C. So where m, the coefficient of x is m, which is equal to what? Which is equal to m is equal to tan theta, which is equal to m is equal to tan theta, where theta is the positive angle, and with the positive angle, which is the angle made by the straight line in anti-clockwise direction. Now the other form of straight line is one point form of the straight line. The equation of a straight line which passes through the point x1 y1 and which makes theta angle with the positive direction of x-axis is y minus y1 is equal to mx minus x1. So here I am just drawing the diagram. Suppose a straight line AB which passes through the one point I have taken, and that point is suppose C, and its coordinate is x1 y1, and it makes this straight line makes theta angle with the positive direction of x-axis, and we are just taking a variable point or general point pxy. So if we will draw the perpendicular from this point C and this point P on both the axes, we are seeing that the perpendicular drawn at the point M or N. So and from C we are drawing the perpendicular PR. So as we know that this figure becomes a rectangle, CRNM is a rectangle, and this is a right angle triangle. Now suppose here the coordinate of the point C is x1 y1, so this distance is x1 and CM is equal to y1, and now we have taken a general point P, so this distance is y, and the distance from origin is this distance is x. So what will be the distance of MN? MN will be equal to x minus x1, and opposite sides of a rectangle are equal, therefore Rn is equal to y1. Rn is equal to y1, and from the figure it is quite clear that quite clear that PR is equal to y minus y1. Now, as this angle is 90 degree, angle R is 90 degree and angle N is also 90 degree, so corresponding angles are equal, then the lines are parallel, therefore this angle is also theta angle. So in a right angle triangle, tan theta is equal to PR by CR, and PR can be written as, what is the value of PR in terms of y and y1? So it is y minus y1, and CR is equal to it is x minus x1, and Mn is equal to CR is equal to x minus x1. Why? Because it is equal to Mn and CR both are equal, so it is equal to y minus y1 divided by x minus x1, and we know that the gradient or slope of the straight line is denoted by tan theta. So it, in place of tan theta we can write m, because it is the notation of slope. So y minus y1 divided by x minus x1, so y minus y1 is equal to m times of x minus x1, where x and y are the coordinates of every point of the straight line. So, and x1 y1 is the particular point through which the straight line is passing. Therefore, this is the one point form of a straight line. This is the proof of one point form of a straight line. So now we are going to the another form of equation of a straight line. Now another form is two-point form. Two-point form of equation of a straight line. Two-point form of equation of a straight line. The equation of a straight line passing through x1 y1, one point having the coordinate x1 y1, and x2 y, and other point is x2 y2, is y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So this is the equation of a straight line in two-point form. Now we have to explain this. So if you will take a diagram, suppose PQ is a straight line which passes through the 2 points which are given x1 y1 and it is given x2 y2, and which makes theta angle with the positive direction of x axis. So y-o y dash, and here is x-o x dash. So we know that the slope of the line which passes through the two given point is equal to it is y2 minus y1 divided by x2 minus x1. Now from the equation of one point form, we know that the equation of a straight line passing through the point x1 y1 and x2 y2, and whose slope is m, is y minus y1 is equal to m times of x minus x1. So now from these two equations, from 1 and 2, we can substitute the value of m here. So y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. So from 1 and 2. So it is, now we are bringing this factor in the left hand side. So y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So now this is the this is the proof of two-point form of equation of a straight line. So with the help of this formula we can find out the equation of a straight line, in which it is given that the 2 points through which straight line passes. Now we are coming to the another form of a straight line, that is intercept form. Intercept form of equation of straight line. Intercept form of equation of a straight line is the equation of a straight line, which makes A as x-intercept and B as y-intercept is x by A plus y by B is equal to 1. This is the intercept form of straight line. Now we are just going to explain it. The proof is not going to ask in the class 11 examination as well as in competitive examination also. So here, so suppose that a straight line is here. We have taken the AB is the straight line which intersect at the x-axis at the point P, suppose. So the distance of this point of intersection P of the straight line AB with x-axis from the origin is A, and suppose it intersects on y-axis at the point Q, then the distance of the point Q from the origin is taken as B. So this is called, A is called the x-intercept of the straight line AB, and B is called the y-intercept of a straight line AB, or you can say that AB intersect the coordinate axis at the point P and Q. So OP is taken as x-intercept and OQ is taken as y-intercept. So what will be the coordinate of the point P? It will be A0 and it will be 0B. So we can find out from the two-point form of equation of a straight line, as we know that the equation of a straight line in two-point form is y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1. So here we are just assuming x1 y1 is equal to a0 and x2 y2 is equal to b0 0b. Therefore we are just substituting in two-point form the value of this. So y minus y1, in place of y1 we are putting 0 because y1 is 0 over here, and in place of x1 we are putting a, and now in place of y2 it is b. y1 is 0, and now y1 is 0, and now here x2 is what? So x2 is 0, so 0, and x1 is equal to b. So in place of x1 you have to write down b. B is just a minute. So here y is as it is, y1 is taken as 0, so it is 0, and then x minus x1, so x is as it is. X1 is what? X1 is not 0, x1 is a, so here a I have written. Y2 is what? Y2 is b, so it is b is written, and y1 is what? Y1 is 0, so it is 0, and here is x2, so x2 is 0, and what is the value of x1? It is x1 is a, So here I have done the mistake, so please sorry for that. So a, so y divided by x minus a is equal to b by minus a. Now we do the cross multiplication. We are seeing that minus ay is equal to bx minus ab. So here we are bringing ab in this side, it will become positive. So bx plus ay. So here we are bringing minus ay in this side and minus ab in this side. So we are getting this. So if we will take it is equation number 2, and we will divide both sides of this equation by ab, we see that ab divided by ab is equal to bx by ab and then ay by ab. So this can be written as bb will cancel over here, a will cancel, ab is cancelled by ab, so it becomes 1. So x divided by a or y divided by b. So we see that x by a plus y by b is equal to 1. So this is the equation of a straight line in intercept form. This can be written as x divided by x-intercept. In language form you can write also, and y divided by y-intercept. It is equal to 1. So this is the very good formula for drawing a straight line, and it is very applicable in linear programming problem also. So now we are coming to the other points in which
Start.
बोल दीजिएगा. So now normal form of equation of a straight line. So we are going to just explain what is normal form of equation of a straight line. Here we are taking the coordinate axis. You will have also understand, see, don't sleep. So x o x dash and it is y o y dash. We have taken here AB is a straight line, and from the origin we have drawn a perpendicular. Suppose the perpendicular is OM, and this perpendicular distance, this length of the perpendicular from the origin is P, and this perpendicular makes an angle alpha with the positive direction of x-axis. That is, this perpendicular makes with the x-axis. Now the normal form says that equation of straight line in normal form or perpendicular form, we can also say x cos alpha plus y sin alpha is equal to p. This is the equation of straight line in normal form. So here if you will take a point P, suppose that point Q I am taking, because the length of perpendicular is taken as P. So we will just draw a perpendicular from this point Q. So QR is drawn as perpendicular. So what will happen, you see that, so as you know that OM is perpendicular to AB, therefore angle M is equal to 90 degree. It is quite clear. And now we have taken angle, suppose this point is T, so we have taken angle MOT is equal to alpha. So in triangle OMT, what is alpha plus 90 degree, M is 90 degree, and this angle we don't know. So suppose this angle is taken as angle QTR. QTR, it is sum of this three angle is equal to 180 degrees. This is 90 degree. So angle QTR is equal to, we are getting, if you will solve it, very simple. So 90 degree minus alpha. So this is 90 degree minus alpha. So this will be automatically becomes alpha, because the sum of these two angles is equal to 90 degree. As we know that in the right angle triangle, the sum of the other two angles is always equal to 90 degree. So this is this. So now suppose the coordinate of the point Q is taken as, it is a variable point xy. So what will be the value of here OR, it is x, and what will be the value of QR is y. So this value is y and this value is x. Now we are just taking sine alpha is equal to sine alpha, or we can take cos alpha is equal to in this triangle for alpha base is y, so y by qt, and sine alpha is equal to, for alpha RT is the perpendicular, RT is perpendicular RT by QT. These are coming. Now just pause. Now we are going to start normal form. उसी में continue. Normal form of a straight line. We are just prove it. Suppose a coordinate axis XO x dash and YO y dash, and a straight line AB intersecting the x-axis at the point C and D, and the perpendicular drawn from the origin is given. OM is the perpendicular drawn from the origin, and the length of the perpendicular makes with the x-axis in positive direction is alpha. It is also given. Now we will have to prove that x cos alpha plus y sin alpha is equal to P, which is the length of perpendicular. So if the alpha angle is given and the perpendicular drawn from the origin to the straight line is given, then with the help of this formula, this equation, x cos alpha plus y sin alpha is equal to P, this is the normal form of the equation of a straight line AB, or any name you can give. So suppose this angle is alpha, as we know that this angle is angle DOC, origin is 90 degree, therefore this angle MOD, it is equal to 90 degree minus alpha. It is quite clear. Now equation of AB in intercept form, in which intercept form we can write x divided by OC, x intercept, and y divided by OD, which is y intercept, it is equal to 1. As we know that in intercept form x by A plus y by B is equal to 1. Now we are coming in this triangle, in triangle OCM. Suppose we are taking cos alpha. So cos alpha is equal to, for alpha the base is this, perpendicular is the base here, this is the base, P is the base, length of perpendicular is base, so P divided by OC. So OC into cos alpha is equal to P. So here OC is equal to P divided by cos alpha. This is taken as suppose equation number 1, and Now in triangle OMD, I am taking cos 90 degree minus alpha. It is equal to base is OM by hypotenuse is OD. So OM by OD, and OM is equal to P, length of the perpendicular drawn from the origin. It is given, and OD is the y-intercept. So as we know that cos 90 degree minus theta is equal to sin theta, so it becomes sin alpha is equal to P by OD. Now OD is equal to P divided by sin alpha. It is taken as equation number 2. We are substituting the value of OC and OD in this equation, which is the intercept form of equation of a straight line. So x divided by, in place of OC you just keep it P by cos alpha, and in place of OD here we have to just substitute P divided by sin alpha. It is equal to 1. Now cos alpha will come in the numerator, x cos alpha divided by P, and this is y sin alpha divided by P. It is equal to 1. So x cos alpha plus y sin alpha divided by P is equal to 1. So x cos alpha plus y sin alpha is equal to P. So it is the equation of a straight line in normal form. This is the proof is not coming. So if the length of perpendicular is given, and the perpendicular makes alpha angle positive angle with the x-axis, then with the help of this normal form we can find out the equation of a straight line. Now we are coming to the distance form or parametric form. So now distance form or parametric form of equation of a straight line. Now here we are going to find out the distance form of equation of a straight line or parametric form of equation of a straight line. So for that, just we have taken the coordinate axis. So x dash is the coordinate axis, and x axis, and y dash is the coordinate axis, and here we have taken a straight line AB, and this straight line passes through the point. Suppose it passes through the point, suppose it is the D, and the coordinate is x1 y1. The fixed point is given, and now we have to find out the distance form or parametric form of equation straight line. For that we have just taken a variable point P whose coordinate is xy. This is the variable point, means any point, variable point of equation of a straight line. This is the variable point, and suppose the variable point is at a distance r from the given point. This is D is the given point, fixed point, given point, fixed point or given point we can write. You can say it, given point, and the distance is this. Now we know that from one point form we know that slope is equal to tan theta. And this is equal to y minus y1 divided by x minus x1. So tan theta can be written as sin theta divided by cos theta. This is y minus y1 by x minus x1. So we do the cross multiplication, x minus x1 by cos theta we are keeping here, and y minus y1, and bring sin theta in this side, it is sin theta. So this is the form is coming, and this is equal to r also. And what is the value of r, we are just going to find out. So suppose that we will do the perpendicular from here, PM is perpendicular, from D PN is perpendicular, and from D this is drawn perpendicular in this way. So we are getting the value, this value is x, and this value whole is the value is y, I think, and this value will be x1, and therefore this value is x1 minus x. So this is x1 minus x, it is a rectangle. Similarly, this value PR is equal to y minus y1, and this angle will be, suppose that this angle is theta, so this angle is theta because both are parallel lines, and this angle is 180 degree minus theta. So here the positive angle is 180 degree minus theta. Here the positive angle is 180 degree minus theta. So now from here, from this triangle, tan theta is equal to y minus y1 divided by x minus x1. Now the slope is equal to here, slope of AB is equal to tan, in place of theta we have to write 180 degree minus theta, because the positive angle will be 180 degree minus theta, and we know that in this second quadrant tan theta is negative, so minus tan theta. So minus tan theta is equal to minus tan theta, so it is minus we can write it is minus sin theta, that's all, the slope of this. And second is, if you will take in this triangle sin theta is equal to what? Perpendicular by hypotenuse. So perpendicular is PR, by hypotenuse is PD. So PR is equal to y minus y1 divided by r, and if you will take cos theta over here, so it is equal to RD by PD, it is equal to x1 minus x by r, please do not click. So y minus y1 divided by sin theta is equal to r, and here x1 minus x divided by cos theta, it is equal to r, So because slope is negative, so we can write x minus x1 by cos theta is equal to y minus y1 by sin theta, it is equal to r. This is the formula of distance form of equation of a straight line. Here we will find out the coordinate of the point xy. So coordinate of the point xy, for the coordinate of the point xy we have to find out, from here we can find out, suppose x minus x1 by cos theta is equal to r. So x minus x1 is equal to r cos theta. Now x is equal to x1 plus r cos theta. So in place of x1, we have it will be given, and now from the second one we have to find out y minus y1 divided by sin theta is equal to r. Therefore y minus y1 is equal to r sin theta. So y is equal to r y1 plus r sin theta, theta. So in these two formula you can find out the general point, and this is the distance form or symmetric form or parametric form of equation of a straight line. I think it will be a clear, proof is clear. So in the next video we are coming to the different type of problem related to straight line from all the different form of equation of a straight line, and some of the theories are still left. Thank you. Please like and subscribe my channel. Thank you.